Let me just make a general comment. I'm fine if you need to do them. No, no, no. I understand that's sort of the flexibility of what I view as an online class is, to a degree, it does allow you flexibility, but that flexibility can be double-edged. It's flexible, so you can do when you want, but it's flexible, and also it means, well, I can just do it tomorrow and do it tomorrow. I do it tomorrow, and then tomorrows stack up. So I get it that things pop up. I know that's the beauty of online, but have in your mind a plan for catching up. And so my plan, my recommendation is hey, set a target date. I want to be caught up by Saturday. I'm throwing something out there. That way you can start clearing out your schedule and saying, sorry, whoever, is begging for your time. No, I got a mission to, for this Saturday, something like that. Anyways, that's sort of what I'm saying there. But if you need to catch up, please do. I get it that life gets in the way, particularly with kids. They're so unpredictable. Uh, they don't come with the manual. Okay. Uh, yeah, and Adam makes a good point here. He says, there were two of them that he found particularly challenging, and he said, I just moved on. I think that's a good plan. If you're finding there's a lesson or two, maybe even three, okay, three's not going to kill you. Each one of these lessons are not terribly worth a lot. So one, two, or three lessons, and you're saying, you know what? I'm going to move on. I'm not getting this. It's not clicking. Move on and go to the next one. Don't spin your wheels just trying to get these points. 10 points ain't going to make or break anything. So just move on. And I think that's a good sort of balancing to say, you know what? I got a couple points here. I'm satisfied with that. It's not a zero, but it's also not 10. Okay, that's fine. We'll deal with that. And what I'm seeing in the progress, and if you go back into your grade book, this is one thing I did change, is I adjusted the test grades to be 100-point test grades. So it's putting a good deal of weight on a much more weight on the tests than what it was previously. So that now, the test will have, so that my point is that one or two homework assignments is not going to make or break anything because the tests carry a lot of weight now in the grade book that you'll see. So that's just sort of a quick update on that. Yeah, so now I'll say Tiffany also reminds me if there's three or four that you're sort of struggling with, that probably means you have questions. Send me your work. Get me involved and say take a picture and send me that picture and say, hey, by the way, what's going on? Or bring your questions here and we can talk about them as well because we are looking for opportunities to review as well. So don't sit in isolation. Don't sit in your own darkness, stressing out about it. You do have an avenue, and also keep in mind the internet. By the way, if you're dealing with say uh, parallel and perpendicular lines, let's say, you can go to Khan Academy, search parallel and perpendicular lines, and you get a guy who's made wonderful videos with a much more pleasing voice than I have. So there is help out there. The internet is a wonderful. YouTube is wonderful. So don't be shy about it. About seeking help, and then ask me. I can probably find a video too, to help sort of do some teamwork on all of it. So you're not alone. I just want to reinforce that. Present me your questions. If you send it, by the way, if you send me your question via email over here, in the Canvas message, I won't tell. I won't tell who it is. I'm not gonna out you and say, Addie's asked 14 questions, so let's get through her 14 questions first. No, I'm not gonna do that. Uh, just joking. You're the only one with your camera on, so you got the one that so that's I'm not going to do that. I'll just say, hey, question popped up. Let's take a look at that and work it together. So, anyways, I invite you all to do that. And I think also just a kind of a quick plug. Doesn't SLCC have tutoring on the campus as well? If I'm remembering right, I don't know. Anybody want to help me out with
Yes.
that? Okay.
Yes. I think it's Tuesdays and Fridays. I've been going when I can. I was
Okay.
supposed to go today, but then my dog escaped, so I had to go get him.
So So good. So that's a good reminder too. That's always there for you as well. And it's nice to get, I think I'm pretty good. but I'm not the best. I always look, you know, I'm pretty competitive, so I do think I'm the best. Uh, but it's great to have another voice because it doesn't always, you know, maybe the way I'm articulating it doesn't click, and someone else has got a way that clicks for you. So get those alternative voices out there too, because you know, everybody wants to help. Is at the end of the day where we're at. Okay, so where are we at? Oh, we were here on section 11.1, but 11.1 is actually going to be merging with one of these other sections here real quick. And 11.1 was sort of interesting in the sense that we talked about this idea of what systems of equations is all about. And what we have is we have two equations with two variables, the whole point of which, and let me turn my video because I'm pretty animated and okay, here we go. So we'll see. Oops, there we go. So my internet is slow. So if I drop off, don't go anywhere. So hold on just a second. Okay, so we have these two equations with two unknowns. The very first thing we're trying to do is understand, trying to categorize the type of system. Is it a solution? Is it a system with one solution? Is it inconsistent or dependent? And we were looking at that yesterday to help us understand what that means. It means the number of solutions, but then two, how can we look at these things and determine whether a system has one solution, no solution, or infinitely many solutions, as well as trying to understand what it looks like graphically. One solution means one intersecting point. Inconsistent means parallel lines, and dependent system means the same line. So just trying to understand what that means graphically, because the next section will be a graphing section and we'll sort of be ahead of the curve on all that. So what we did is we looked at this one problem right here, and we said, well, there's two ways to look at it. You can look at it from a slope point of view, like you did in the prior units, and say, okay, well, hey, what are the slopes of the lines? Because if they're different slopes, that means they have one point of intersection. If they're the same slope, then it could be inconsistent or dependent. It depends upon what the y-intercept is. So same slope, different y-intercept means parallel lines, inconsistent, but the same slope, same y-intercept means they're the same line, dependent system. That was one way we did it. The other way we did it is we took a look at the substitution method and said, oh, we can actually solve the system and determine if it's the solution as well. And there we said, when you apply these solving methods, the variables go away, both x and y go away, they're eliminated. If you get a true result, it's a dependent system. If you get a false result, it's an inconsistent system. So that was kind of where we left off yesterday. So let me go back to my PowerPoint. I found it. Where's that? I did find it. Okay, here we go. So we were on this, and where we were at was the end of the substitution method, which was right, I'll find it. It was very long. Right here. We're here. Okay. And we found that, and remember what we did is we'll sort of just back up. Remember what we did is we took the top equation, 2x plus y. In the substitution method, we're looking for a plain variable, a plain x or a plain y, okay? So we took the top equation, 2x plus y equals 1. We solved it for y, solved it for y so that we could get this thing right here, y equals 1 minus 2x. So we took the expression 1 minus 2x and plugged it in for y into the second equation. So we took this y right here and replaced it with 1 minus 2x. And now we've got one equation, one variable, solve to find x, use your normal process, and we did that, finding the x value is 0. So then once we found our x value is 0, we went back to the original system, plug in 0 for x, and to find the associated y, and we found it was 1. So we found that the ordered pair, the solution for the ordered pair was 0, 1. It's just one solution. One point of intersection. One point of intersection. That point of intersection being 0, comma 1. And the cool thing about it is that the 0, comma 1 will be a solution to both equations. It'll work in both of them. Work in both of them. So if you plug in 0 for x and 1 for y, it'll make true statements for both of them. That's the whole point of it. Okay, so what we want to do now is we want to switch gears. Remember, there are three methods: substitution method, which is what we see here, elimination method, and graphing method. So let's go to the second method, which is the elimination method. And we call this the elimination slash, excuse me, the addition method. Why do we call it the addition method? You'll see in just a second. Okay, so the elimination has the same goal as the substitution. Is we want to get rid of one of the variables. We honestly do not like working with two variables, so we will get rid of one. But we're going to go about it in a different way. The process, I'll say the process, it's really not going to make any sense to you. It's a little more clear when you see it in action, but here's the process. What you do is you pick a variable. It can be X or it can be Y. It really doesn't matter. You all could pick X and I could pick Y and we'll get the same thing. It does not matter which one you pick. But when you do pick a variable, your goal is to get the same value in front but different signs. Same value in front but different signs, for reasons why we'll see in just a second. Okay, so let's take our system. This is the same system we worked with just a second ago. We know the solution. We know we're going to get 0 for x and 1 for y. So we're not worried about what the values are going to be. This better be it. And if we don't get this, we've done something wrong. Why? Because it's the same problem. And so I'm doing this on purpose to show you that you can use the substitution method or the elimination method and get the exact same thing. And at the end of the day, that means you can use either method, whichever one you like. And candidly, just a full disclosure, I personally hate the substitution method. It's my least favorite, even above the graphing. But most students who go through this love the substitution method. They prefer it over everything else. For me, I prefer the elimination method. It's my favorite one. I find it to be the quickest one to work with. So it's a matter of taste and choice. That's wonderful about this method. Okay, so let's see it in action. We know what the answer is going to be. X is 0, Y is 1. No mystery there. So what you want to focus on then is the process. How do we get there? That's the thing. So what we want to do is, if you take a look at the numbers in front of the X's, they're not the same, okay? So look at the X's. Look at there's a 2 and a -5 in front, not the same. Look in front of the Y's. It's a 4 in the bottom. It's a 1. Remember, it's a plain Y. That means it's a 1 in front, okay? Just to kind of give you a heads up. So I'll write the 1. That's fine. So remember our goal. Pick a variable, and you want to get the same number in front, but different in sign. I'm going to throw it to you all. You get to pick. Do we want to get rid of the X, or do we want to get rid of the Y? I'm good with either one. First one that says it gets, that's the one we're going to do.
We can do the Y.
Okay. Okay. Guess what? I'm going to do both. Okay. Just to kind of sort of show you. So we're zeroing in on the Y's. Okay. So we want let's start off with the same value. The same value. How do we get the same value in front? And what we're going to do, what I'm going to do is I'm going to get an analogy going for you. Suppose we have, go back to the days early in the session when we had something like this, 2/3, and we wanted to add, I don't know, 4/7. Okay. Remember the rule for adding fractions. What do we need?
Same denominator.
Same denominator. And how do we get that? So this is the part I want you to really hone in on. How do we get the same denominator? Do y'all remember articulating that process?
Multiply each denominator to the opposite fraction. or some
Yes. So yeah, I think I think I understand. I think that's a good way of
articulation.
sort of saying it. So, what am I going to do to the 2/3 under your process?
Multiply by 7.
Multiply what?
Multiply the top and the bottom by
The top
7.
and the bottom by the 7. Now, why did
Or
you choose 7?
because it's the denominator of the other fraction.
Boom. That's the thing. Is you took the denominator of the other one of the second fraction and multiplied it to the top and bottom of the first one, and then complete the tail. Take the denominator of the first fraction and use it to multiply it to the top and bottom of the second fraction. That was the process, and by doing that, we got common denominators. This became 14 over 21, and then plus what? 12 over 21. Why do we go? What's so important about this? Is because that's the process we're going to use up here. Remember what we want. We want these numbers here in front of the y's to become the same. We're going to utilize the process down here that we did previously. So let's do that. So take the number here. So take the four here, and you multiply it to the top and bottom. Now, I'm sorry, to the top. But you're going to do it to both sides of the equal sign. So take the 4 from in front of the y and multiply it to the top. And then do what? Take the 1 in front of the y, oops, and multiply it to the bottom. Do y'all see that? Why I did that? Okay, so I'm going to come over here now. And so now you got to sort of clean it up. Do your actual multiplication. Multiply that 4 in the top all the way through. That gives us 8x plus 4y equals 4 on the left. And then multiplying the bottom one by 1 doesn't change anything. So we get negative 5x plus 4y equals 4. Okay. Okay, so here's what we got. Now, what we want to be able to do is we want to add these fractions, and this is why we call it the elimination method. Add the fractions. The goal is that when you add add the fractions, add the equations, add the equations. The hope is that when you add the equations, the variable that you're focusing on will go away. So if I were to add them as is right now, would the y variables go away?
No.
No. What's missing? What do we need?
A subtraction symbol in front of one of them, and
One of
only
them.
one of them.
So let's go back then over here. Okay? Let's go back then over here. Remember the goal, and that's why we have that goal. The same value in front, but different sign. Okay? So how can we make a different sign? Well, instead of multiplying by positive 4, we can go ahead and multiply by negative 4, and then negative 4. Just as long as we multiply by the same thing on both sides, we can multiply by anything we want. So let's just go ahead and do it by negative 4 at the top. So when we do that, we get negative 8. Not going to let me do it, so I'll just erase it. So that becomes what? Negative 8x minus 4y equals negative 4. Then bring down the bottom one, equals 4. Now I have negative 4y in the top and positive 4y in the bottom. So now when I add them, the y's, they will indeed go away. They're going to add to give 0. So the key to the elimination method is pick a variable. It does not matter. I'm going to show you it doesn't matter. So we're focusing on the y's. We said, I don't like y. Let's get rid of them. Get the same value uh, different in sign. What that means then is take the value in the bottom fraction in the bottom equation, multiply it to the top equation, take the value from the top equation, multiply it to the bottom equation, adjusting for sign. So now when we add these, so once you get the same values, you add these, this negative 13x on the right side, left side, and then negative 4 plus 4 on the right side gives us 0. Now we solve for x, solve this thing for x. And how do we do that? Divide both sides by negative.
Divide by negative 13 on both sides of the equation.
So I'm running out of room here. You can see them. So I get x equals 0. Exactly what I thought I should get. Remember, we know the answer is x equals 0. So we know we're going to get y equals 1 as well. So let's see this again. But this time I'm going to get rid of the x variable. I want to show you, I want to prove to you that it doesn't matter which variable you get rid of. So we picked y first. Let's pick x now. So, but you tell me this time, what am I multiplying the top equation to by, and what am I multiplying the bottom equation by? That's the question I want to throw to you. So we're honing in on the x's. We want to get them to be the same value but different sign. So what do
Would
I
you
Mhm.
would you multiply the top by -5 and then the bottom by +2
Almost perfect.
or
So
negative five and
let's hone in on your first one. You want to multiply the top equation by -5.
okay,
What's that going to give me?
-10 plus -5,
And if I multiply the bottom one by +2, what's that going to give me?
-10 by 8y.
Right. So I have negative 10x in the top and negative 10x in the bottom.
We have to multiply. We have to make the 2 a negative.
So
Wait,
instead of
no.
all the extra negatives, and so I want to step back, but you're almost there. You're almost perfectly there. Notice we've already got them to be opposite in sign. Remember
Oh,
that's our two goals. Same number, opposite in sign. They're already there for one of them, opposite in sign. So we don't have to worry about the negative part when we do our multiplication because it's already got our one, it's already got that component. So instead of -5 in the top, just multiply it by a +5. You see why I'm doing that now?
yeah.
And then the bottom one, you were right. I agree. Multiply by 2.
Okay.
Jenny, you sound like you got a cold.
Yeah, I got. I emailed you. I didn't know if I'd be able to participate because I got tested positive for COVID today.
Uh, Maybe
Yeah.
I had that too. I was zonked out over the weekend.
Oh,
So now
well,
we
they told me.
multiply. Yeah, it's that time
Yeah.
of year. Oh, I stayed up late last week. I'm not taking care of myself with sleeping. It's the bane.
Right. I understand.
I never do a good job of that. So so notice, when we do this, and Jana, by the way, perfect on the multiplication. Very strong skills of the distributive property. That's great. It's exactly where you want to be at this point of the session. So perfect. So notice what we did is we were being a little strategic here. So we didn't need to multiply the top by the -5. It was okay to just do the plain +5 because we already have the minus sign. So that was the lesson I wanted to cover. Now we can add because we have the same value in front but opposite in sign, so we're guaranteed to go away. So they do go away. And the bottom becomes 13y on the left equals 13 on the right. And so that's going to give us y equals 1, which is exactly what we wanted. So Why do I like the elimination method? Because if you notice, I don't have to worry about a big long equation. I just get the same numbers in front, and the resulting equation is pretty, I hate to use the word, but easy. It's not too, it's not terribly. It's pretty satisfying. I'll say it that way. But this is really more the process over here. Any questions on this process for the elimination method? So now let's see it in the other one, the other problem. Our friend right here. We know what the answer is going to be, by the way. There's going to be zero surprise. We know it's an inconsistent system. Why? Because we did it one way, telling us it was different slopes. I'm sorry. No, this one was same slope but different y-intercept. That's why we knew it was inconsistent. We did it that way. We did the substitution method, and remember the substitution method, we got 72 equals 64, and we were like, no, that's a false statement, meaning variables went away, false statement, inconsistent system. So we know what the answer is going to be. So let's see how it looks doing the elimination method. So you pick. Do you want to get rid of x or do you want to get rid of y? Again, it doesn't matter. Whichever one you want. And there's no better choice. There is honestly no better choice. So it doesn't matter. X. There it is. See? Just make a choice. And I'll tell you what. President Obama articulated this concept. I heard him say it years ago, so I always attribute it to him. But he's not the one who said this. He just conveyed the message. Sometimes you get what we call decision overload. You make a million decisions in a day, and so you're like, you know what? I don't want to make another decision, especially for parents of young kids. You're like, ugh, my wife just did that. I don't want to make a decision. My point is this: I always pick X to eliminate. Almost always, 99% of the time, almost always. Why? Because I don't want to make a decision on this. I just want to do it. So if you ever are stuck, which one should I pick? Pick X, always. Why? Because it's the first variable. There's no reason. If you don't like Y, get rid of Y. But my point is just pick one and go for it. So we're going to hone in because Addie chirped up first. I saw her X. We're going to pick the X's. So what do I need to multiply top and bottom by? The top equation and the bottom equation by. If X is going to be the thing the top equation, we got to multiply by 3 because we have a 3 right there. We don't need to do the negative 3 because we already have a negative in front of our 3 right there. So we've already got different signs, check. We just need to get the same value. So multiply the top and bottom by 3. I'm sorry, left and right of the top equation by 3. And when we get that, I'm going to come down here. 3x minus 15y equals negative 72. Now this is negative 3x plus 15y equals Am I back? Okay, let me go back. Okay, so there it was. Let me take my video off because I think that's part of the problem. Could be. There we go. All right, so good. Thank you for not leaving. Okay. So okay, good. So we multiplied the top one by 3. That's where we're at. The top one by 3. And so when we do that, I'm going to come down here. 3x minus 15y equals negative 72. So it's negative 3x on the bottom. We just carry the bottom equation down. Equals 64. Okay, so we're good. We're good. We've got we were honing in on the x's. We got the same value in front but different signs. Good. So now we can add. And so when we add the x's, 3x plus negative 3x is 0. 15y, negative 15y plus positive 15y also is 0. So the left-hand side becomes 0, and the right-hand side becomes negative 72 plus 64, which is, looks like negative 8. Look at that. Both variables went away. Both variables went away. And it's a false statement. It's a false statement. Okay? So because both variables went away and it's a false statement, the solution is an inconsistent system. So we would get the same result even by doing the elimination method. Questions? Okay. All right, so that's pretty much it. I mean, that is systems of equations. And so now it's just more of the same, more of the same. So I'm gonna skip this one. More of the same. So what I'm gonna do is I'm gonna skip this one, but move ahead to a different thing. Oh my goodness, I can't believe they did this. Ugh. Okay, well, this is not something that I would pose to you on a test, but let me show you how you would do it, okay? Yeah. So it's the same idea. Let me put my video on. I'm weirded out by it. Sorry. Okay. If you notice when we had equations that were inconsistent or dependent, if you notice the variables, the values in front of the variables, they were kind of up close, weren't they? If we just multiplied one of them by a number, we would get the other one. So you kind of what the way that you could sort of do this is take a look at just focus on one of the variables. Focus on one of the variables, okay? And look at the numbers in front. 4, 1, and 5, okay? So you sort of just look at it and you say, well, what would it take to get them to be the same thing, okay? So you're looking for like what we call a least common multiple or something like that, okay? So what value does 4, 1, and 5 go into? Okay, that value is 20, just to kind of make it quick. So you want to get 20. You want to turn these numbers in front into 20. So how would we do that? Well, you multiply the top equation by 5, multiply the bottom equation, the middle equation by 20 because that's a 1 in front, and the third equation by 4. You don't want to actually do it, okay? But what you want to do then is take a look at another one, okay? And ask yourself, if I do the multiplication to those variables, to the second one, okay, will I get the same number? Will I get the same number in front? And if the answer is no, I won't get the same answer in front, it's one solution. It's one solution.
You mean the same number as the first variable? So if you don't get
No, no,
20,
no. It'll be something different. It may not. It may or may not be 20. I don't know. But just the same number in front of the y. The same number in front of the y. So you can see when we do that, here, the second the variables, the values in front of the y's will be a 5y, will be a 120y, and will be a 20y. This right here. So they're not the same. So it's not
and that,
producing anything. So that's what they're not the same. So it's not
and what are you
producing anything.
multiplying to get that?
Well, it was this right here, the 5, the 4, and I multiplied them to the values in front of the y.
Oh, okay, the same value. Okay, I see
Yeah.
what you're saying.
So that's sort of a shortcut way of looking at it and saying, how do I know if something with 3 variables is going to give me something with one of these things? And the way to sort of look at it, remember these two right here, inconsistent and dependent, when you apply the elimination or the substitution method, the way that it ends up happening is that all the variables go away. So fundamentally, that means the values are going to be the same in front. Values are going to be the same. So that's your test. What does it take to get the same here? Multiply the equations by that necessary value and see if you get the same value in front of the y's or the middle one. Okay? And if you don't, it's not going to work. It's going to blank you. It's going to blank out. 9 times out of 10. I'm giving you a shortcut that's not really a shortcut, but I'm giving you a shortcut that'll work on a lot of problems. Because this one, I have to probably say, I would never have asked it. I don't like this question at all. And the reason is because this particular question is more geared for what I call an Algebra 2 class, Algebra 2, or even what we call linear algebra. It's a higher class, a higher mathematics class. I don't like this one, but it is still cool in the sense that where would you see something like this with 3 variables? Where would you ever encounter this thing with 3 variables? Not that you'll ever do it, but where would you encounter it? When you fly an airplane, if air traffic controllers, the planes are moving in 3 dimensions. So that's why you can have two airplanes look like they're coming head on, but because they're at different altitudes, even though they're on the same line, the same plane, they won't intersect. So it's because of the 3-dimensional aspect. You can have two airplanes coming, crossing paths, but because they're different altitudes, they actually don't cross paths. So that 3 dimensions is what I'm saying there. Not that it's important, but anyways, I'm glad we looked at that. So here's another one, same sort of thing. Okay. So this is a word problem. I'll talk you through the word problem. So this says a private jet flies in the same distance in 4 hours that a commercial jet flies in 3 hours. If the speed of the commercial jet was 168 miles per hour less than 2 times the speed of the private jet, find the speed of each jet. I'm sorry. Okay. So so read it again. A private jet, not just regular people. Well, regular. Private individual, not commercial airline, is going away 4 hours, and a commercial jet is going the same distance in 3 hours, and then they tell you the relationship of the speeds. The commercial jet is 168 miles per hour, less than twice the speed of the private jet. Okay, so keep in mind the lesson that we're in, systems of equations. Okay, and what do we know about systems of equations? 2 equations with 2 variables in them. So that's what we want to build. We want to build that sort of thing. Okay, how are we going to do it here? Well, what we need is what's called the distance formula. Distance equals rate times time. Distance equals rate times time. What do we know? Well, let's take one of them. Let's take the private. The private jet flies a distance in 4 hours. How far does it fly? I don't know. So, but the private jet goes a certain distance in 3 hours. So the T is going to be 3. I don't know what the R is going to be, though. Okay. So instead of writing this as R3, why don't I write this as 3R? But do you see how I got this? This is for the private jet. The private jet. Do y'all see how I got this? All I did was I said, well, it covers some distance in 3 hours. I don't know what the distance is, though. They're not telling me. You can pick your distance. You can make it arbitrary what you want, but I don't know if that's going to be helpful. So that's why I'm not doing it. But let's take a look at the other one. The commercial jet. Oh, wait. I'm sorry. Private jet flies it in 4 hours. I messed up. I was wrong on that. Not 3, 4. Apologies. The private jet, I'm sorry, commercial jet flies it in 3. So its equation is D equals 3R. Now they're not really the same R, by the way. One is commercial, one is private. One is commercial, one is private. So this is maybe little r, and this one here is capital R. Okay, we just want to show that they're different R's, but it's the same D for sure because they're covering the same distance. The problem is telling us that. Okay, so we actually have 1, 2, 3 different variables. We need to get rid of one of the variables. We need to get rid of at least one of the variables. How are we going to do that? Well, that's where the second sentence comes into play. The second sentence. Okay? So we have to translate that. It says that the speed of the commercial jet, okay, that's our capital R that I'm using over here. The speed of the commercial jet is the same thing as the word is. Was and is mean the same thing. Equals 168 miles less than 2 times the speed of the private jet. So remember, less than means subtraction. 168 less than, we're taking it away, twice the speed of the private jet. So that's the expression we use. And we're going to take that expression and plug it in for capital R right there. Questions on that part? So let's do that. So I got the bottom equation, D equals 3 times 2R minus 168. So remember what we need. We need 2 equations with 2 variables. So I have one of my equations is right there, and my other equation is right there. So let's write those over here. D equals 4R, and then D equals 3 times 2R minus 168. Now the cool thing is, these are the same D. So because D is 4R and D is also 3R minus 2, what that means is we can set the two things equal to each other, giving one equation right there. 4R equals 3 times 2R minus 168. Now we just solve for R. What was that, 24? Anybody want to tell me what that is? 504? Doesn't feel like it. It is. Okay. Then we subtract 6R minus each side. And then we divide by 2 to each side. 252.
It should be, I think it's supposed to be 672. Wait, we're doing 4 times. Wait, hold on. Let me see where I'm at. Oh, no, 3 times 168. Okay, I'm sorry.
No, you're all good.
504. Okay.
So what's the speed of each jet? So what we found here is little r, the speed of the private jet is 252. And that now we put that in right here. So the speed of the private jet is 252. Plug it in 252 here to find capital R for the speed of the private jet. And that's going to give us 336. Let's see. Yes.
So what did we do to get to 336?
You plug, you plug the 252 in for this R right here. So that gave us 2 times 252 minus 168.
Okay.
And you simplify that and you'll get the 336.
Okay.
It works. Good. Voila. So, but the point is the reason why I wanted to do this one is because you probably hadn't or probably weren't even thinking of this formula: distance equals rate times time. So when you hear of distance, speed, time, this is the formula you want to use. And then it kind of brings it back in all the stuff from translating word problems back again. Excuse me. Okay, questions on this one? Check my calculation right quick. Okay, good. Alrighty. Let's keep pressing forward. Let's see what we got. Ugh, more. Use any convenient method. Eh, I mean, it's still looking like, let's see, y equals 3z, 3z, 1. Yeah, it looks like it's going to be 1. So, oh. Here, what's interesting. Here, what's interesting is that notice this one doesn't have a z, and this one doesn't have an x. So, what does that mean? And what it means is that these particular equations here, the top and the middle one, they're not going to create a line. They're going to create what's called a plane. Okay, you think of like a Superman 2. Remember, everybody, I'm probably aging myself real quick, but Superman 2, that's where you had Zod. Um, they came down, but remember what they were in? They were like in this floating mirror, floating through space. Well, they were a plane. Think of a no, turn your iPhone to the side. That's a plane, okay? And so this is a plane that stretches out infinitely many ways, or infinity, but it's just a piece of paper flying like this. So what you have then is it's possible for lines to miss each other, but this thing is because it's gonna hit the plane. So what you have then is you have two planes here probably crossing, and when you have that, they're probably going to intersect at a they're probably going to be inconsistent. Is probably what my bet would be. That's just a big old bummer. Let's see what the answer is. I'll tell you what the answer is. Oh, submit answer. My answer is incorrect. We'll try again. Ugh, terrible. I don't like it. What I'll do. Let me do this. Let me come back and I will show you. I'll get a video, either A, or show you an easy way to do this. Because I don't like the, or maybe I'll just give you credit for it because this is just terrible. I don't like that problem at all. I'm more inclined to do that. Anyways. Okay, so let's move forward because then we can get to the real heart of it. Then let's go forward then to 11 point R point 2. I'm jumping ahead, but it's the substitution method, and it's what we already know. It's just a review. That's what I wanted to get to, a review of the substitution method. So here we go. This is a perfect one. Substitution method. Remember what we're looking for in the substitution method is um, we want to pick a variable that has a plain x or a plain y. So pick an equation, I'm sorry, with a plane x or a plane y. Which equation has a plane x or y? Top or bottom?
Top.
The top. So what do we do with it? You pick on it. You pick on it. You bring it over. And you work with it. So you take your 8x plus y, and what we're honing in on is the y. It's plain. There's no number in front other than 1, which is what we need. So you want to solve for y, meaning you want to get y by itself. How do we get y by itself here in this equation? How do we get y by itself?
Subtract 8x from both sides.
And so we get the new equation right. Y equals negative 8x plus 18. That's step 1. Now what's step 2? Take the equivalent expression. We wanted y by itself, so take the other side of the equal sign, and you plug it wherever you see a y in the second equation. Replace it with the new expression minus 8x plus 18. So take our second equation, 4x plus 4y equals, is it negative 12? It is negative 12. Wherever we see a y, you're going to replace it with minus 8x plus 18. Y'all see that? Okay, good. And now we just solve. Solve to find x at this one. So this becomes 4x minus 32x plus, what is that, 72? Equals negative 12. We want to combine 4x minus 32 is going to give us negative 28x plus 72 equals negative 12. Now we want to move the 72 from the left side to the right side, but we just don't move it. We have to add the opposite. When you want to move a term, you add the opposite. So that gives us negative 28x. When we subtract from both sides, we get negative 84. Finally, get x by itself means we divide both sides by 28 or negative 28. And so we get x equals, is that 3? It is 3. Boom. So when we plugged in we plugged in the equivalent expression right there. Then we solved for x to find, x equals 3. What do we do from here? We found the value of x. Now we need to find the value of y. How are we going to do that?
Substitute. Substitute 3 for x in the equation.
Which one? Which equation?
In the equation.
You said the top one?
Yes, 8x plus y equals 18.
Works for me. By the way, that's another thing I never decide on. I always say I'm plugging it into the top one. I don't care.
Okay, yeah.
So I don't have. You could do either one, but just make it easy. Just have a process. So plug in that 3 for x and solve for y. And I'm sorry I used pink because it's very hard on the eyes. On this particular one at least. So this gives us 24. Let me maybe change my color ink. 24 plus y equals 18. And so that means what? Y is what? means that y will come over here. Y is -6. So our xy solution is what? 3, comma, -6. And that's what you're going to write over here. 3, comma, -6. And that means how many solutions? Is it one solution, no solution, or infinitely many solutions? Just the one ordered pair. And by the way, I argue that even when it says, well, I'm not going to confuse you. We'll move forward. Okay, this one says they want to do it by substitution again. But when I see this, look at this. Do I have a plain X or a plain Y?
No.
No. I would say even though they're telling you to do the substitution method, if you don't have a plain X or a plain Y, do the elimination method. My point is you don't always have to follow the directions. No. You can buck the system too because another method. Uh, the elimination method can help us out on that. And so, um, what would we get? Huh, interesting. So pick X or what do you want to do? Pick X or pick Y?
X.
X. Boom. Okay, so we're going to hone in on the X's. We want the same number in front but opposite sign. So what do we multiply the top equation by? What do we multiply the bottom equation by?
Multiply the top equation. Since they're both the same sign already, we need to make one of them a different sign. So maybe multiply the top equation by -9.
I like it. Okay, good. Multiply by the bottom one, the top one by -9. Good. And the bottom one?
By 2. Multiply by 2.
By just a plain 2. Right. My handwriting's getting a little terrible here. The bottom one by 2. Good. And then we got to do it to both sides. And so what do we get?
-18.
Plus 18y equals.
Oh, would it be
Oh,
-18?
it would be. That's right. I got a sign error. So -18x minus 18y equals positive 18. Bottom equation is positive 18x plus 18y equals -18. All right. Now we can add these. So when we do that though, the x's go away. -18x plus positive 18x is 0. The y's also happen to go away. That's a coincidence. Doesn't always happen like that. So that's 0 on the left side. And then on the right side, 18 minus 18, also 0. So this is a true, both of the variables went away, yielding a true result. So which of the solutions will it be?
Dependent.
Yeah, so how many solutions does that correspond to? 1, none, or infinite?
Um, oh, okay. Hold on. Infinite number of solutions. Infinite.
Infinite. Booyah. That's right.
Okay, I have a question.
Uh-huh.
Does it matter, like if you don't have a positive and a negative to start off, does it matter which, if you do the top equation or the bottom equation negative?
Nope. It'll
It
come
does
the
not.
same.
Okay.
So now it's just really more of the same. more of the same. So here we go. This would be a good candidate for the substitution method because we got a plain y. So let me pause. Any questions on the elimination of the substitution method? Yeah. So this is same thing. Oh, so because we finished this, so this one here, by the way, has decimals in it. If you notice that, just like with fractions, you don't have to keep the decimals. How can we get rid of decimals? Uh, look at the number of decimal spots. Look at one equation. How many decimals? What's the most number of decimal spots you see? Only one. So you can multiply both sides by 10. Multiply both sides by 10. And that'll clear out your decimal. If you don't like working with decimals, you don't have to use it. But if you're okay with decimals, it works the exact same process. The decimals doesn't change it. It just changes the look a little bit. So if we were to do that, do the 10 at least, it would turn into this. 2x plus 5y equals negative 131. And the bottom would become 4x plus 10y equals negative 262. Okay. But that's probably not where they want you to go. Why? Because you have a plain y here. That's good for the substitution method. So, you don't have to get rid of your decimals. I just kind of presented it there just in case you don't like decimals, but really the decimals doesn't change the process. It's just, you got to keep track of and work with decimals, which isn't always fun. Excuse me. Okay. Excuse me. More of the same. This one's kind of cool though. This one's perfect for the substitution method because remember what we're trying to do with the substitution method. We want to hone in on a plain x or a plain y. Once we do that, we want to solve for that variable. But if we look at the top equation, notice the variable y is already by itself. It's already been solved for. So there's no work to do on that. All we do because of that then is what? Take this part, the negative 4x plus 23, and plop it in for y into the bottom equation. Some of the work has already been done for us in this case. So that's what they want you to recognize, is to say when you're doing the substitution method, what you're looking for is, or hoping to get, y equals something or x equals something, a variable by itself already. And so when we do that here, what do we get? 2y equals 4x minus 26. Plug in, 2y equals 4x minus 26. So for y, we plug in that equivalent expression, negative 4x plus 23. Now we solve this equation for x. So multiply the 2 inside the parentheses. Now here we're going to subtract 4x to move it over to the left. We're going to subtract 4x, and we're going to subtract, so we subtract 4x from each side. And that gives us negative 12x plus 46 equals negative 26. Now we subtract the 46 from each side, and that's going to give us, well, they love the negatives here, don't they? Negative 12x minus, looks like 72, and then divide both sides by negative 12. And that's going to give us x equals negative 6. So x equals negative 6. Oh, I'm sorry, not negative, positive. Because this thing here should have been negative 72. So this is wrong. X equals, oops. It's x equals positive 6. Then come up here to the top equation again and plug in 6 for x. So once you find your value for your variable, go back to the original equations and plug it in. So this is negative 24 plus 26, and that gives me y equals 2. So y equals 2, and then x equals 6, so that's 6 comma 2.
And it'd be one solution, right?
Yeah, let me check to make sure it's right. Oh, I do have a mistake. It's not 2. I used 26, not 23. Negative 1. That's right. That's right. Whew, okay. Sorry about that. I was looking at the 26 in the second equation. Okay, let me pause here. Questions on elimination method or substitution method? Because we've got one more method to do. And the one more method is actually something you already know how to do. It's just kind of connecting it back to what we did previously. So let me go to that. It is right here. Graphing, section 11.R.1. Okay, yeah, do that. So graphing really does mean graphing, by the way. And so what we're going to do is essentially just, remember what we have as systems of equations. We have two equations with two variables. Okay, so each equation makes its own line. So essentially we graph the lines and see where they intersect. Now the first question here says, given the points here below, which one of them is a solution to the system? In other words, if I were to take each one of these and plug them into the system, which one works? Works in both. Which one works in both? Okay. So the way that you do this is you say, okay, well, let's take the first ordered pair and plug them into both equations. Plug them into both equations. Okay. Whoops. I don't know what I'm doing there. Plug them into both equations. So take the x minus y. What I mean by both equations, I mean both, this right here. Okay. Use x equals negative 5 and y equals negative 7. Where did that come from? It comes from the ordered pair, negative 5 comma negative 7. Remember, x is always first, y is always second. So do the top equation, plug in negative 5 for x, negative 7 for y, and see if it gives you a true result. So this is negative 5 plus 7 equals negative 2, and that gives us 2 equals negative 2. That's false. So what is this telling us? This ordered pair right here made this top equation false. It has to make both of the equations true. So it did not, so when it says false, it means it doesn't work. It's not a solution. In other words, this ordered pair here is not a point on the line. It's not a solution to the line, to the equation. So what we want is when we plug in the ordered pairs, we have to get true, true. Okay? It has to work in both of them. It has to work in both of them. So we know this one does not work. So now go down the list. See which one works. So now take this ordered pair right here, go back to the equation. So x minus y equals -2. Plug in -2 for x, 2 for y, and simplify. So this is -4 equals -2, which is false. So this one also doesn't work because it made the top one false. Made the top one false. We can't have that. So now try this one. -3 comma -1. So start with the top one. -3 minus -1. So that's -3 plus 1. Oh, -2 equals -2. That's true. Are we done? No. All we did is we got a top equation of true. Now we got to check the bottom equation, and it has to also be true for it to be a solution. So go to the bottom equation. Plug in -3 for x and -1 for y. So that gives me 9 plus -1. 9 plus -1 is indeed 8. So this is also true. So we got true, true. That means that yes, this guy is the answer. And so we don't have to test this one. We know it's not the answer. We know it's not the answer at this point. So when it says see if determine which of the given points lies on both systems, lies on both lines in the system, what it means is take the ordered pairs, plug them into both equations, and you have to get a true true. If it gives you the if it makes the top one false, it's not a solution right away because it's not a true. But you can need true true. Let me pause. Questions on this one? Okay, so let's go forward then. Same thing here. Plug in the ordered pairs to see which one gives you, and what you're looking for is when you plug in the ordered pairs, you want to get true, 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 true. So here's the other problem now. Okay. So what they're showing you here on this one is they have the solution and they turned it into a graph. Okay. So what that means is that each equation corresponds to its own line. So this one right here corresponds to this line right there. And this equation down here oh, whoops, nope, wrong. This equation here corresponds to this line, and this equation right here, let me change my coloring. This equation right here, it won't let me do it. Bear with me a second. I don't know once. This equation right here is this line right there. And then the bottom equation is this line right there. That's what this is. When we turn it into graphs, when we turn it into pictures. Okay, so determine the solution of the system represented by the lines. So remember what we're looking for. So what you do is you graph each line and put it on the same XY axis and see where, if at all, if it intersects. So when we scroll down, we see that we're looking for the point of intersection. It's that thing right there. What's the ordered pair? What's the XY ordered pair for that point of intersection? Can you see it? How do we find it? Remember, you just go up, oops. You go up to the x-axis. Where does it hit on the x-axis? Hits on the value of, 1. And then you go over to the y-axis. Where does it hit on the y-axis?
-2.
-2, right. So that's the solution. Whoops, not -1. 1 comma 2. 1 comma -2, sorry. 1 comma -2. That's all you do. Graph the top equation, graph the bottom equation, and see the point and find the point of intersection. And that's it.
Um, can you show us how to graph the equation one more time?
How to what?
How to graph the equation one more time?
Yeah. So I'm going to keep these here because we already see the graphs. Okay. That's going to help be our guide. So let's take this one right here. 4x plus 3y equals -2. The process is what? Pick a value for x or y, whichever one you want. It's fine. So what value of x or y do you want?
So you could choose any.
Huh?
Choose any.
Yeah. So let's pick 1 for x. Okay.
Okay.
So come over into this equation right here, the top one. That's the one we're focusing on for graphing. Okay. And plug in 1 for x. So I'm going to plug in 1 for x. I'll get it one day. Equals -2. Solve for y. So this is 4 plus 3y. Let me use my pencil. My typewriter, actually. So this becomes 4 plus 3y equals -2. Subtract 4 from both sides. So that's 3y equals -6. Now divide both sides by 3. And that's y equals -2. So we come over here. My y is -2. So 1, I happen to just find the point of intersection. So the point is we're just graphing those, so we don't know. Okay, what's another value of x or y we could use? Well, let's try the value of I don't know. Let's see. I'm going to cheat a little bit. Let's use the value of 5. I'm cheating. I'm straight up cheating. I'll tell you because I can see it's right there. So these are challenging ones to do. These are challenging ones to do. So I'm going to come back over here to my equation. I'm going to do 4, plug in 5 for the x, and solve for y. Let me get my typewriter. So this becomes 20 plus 3y equals, oops, -2. Sorry. Subtract, oof. Is it -2? Oh, that's funny. It's not going to work. Well, choose something else. Not going to work. We want nice, neat numbers, and that's not going to do it for us. Try again. That's not going to work. What else could we pick? Let's do one that's easier to graph. How about that? This is just, but this goes back to that whole review of pick a value for x, plug it in, find its corresponding y value. So let's move on. because I think we're going to get one where we can actually do it. Yep. Ugh, really. I don't know why they do this. They give you the challenging problems first.
Mm.
Have you noticed that? We start out with the very challenging problems. I'm going to move on. Here we go. This is a lot better. Goodness. So let's graph the top equation. Okay. So do your chart. Do your XY chart. Pick your values for X. What value of X do you want to pick? Zeros, ones are certainly fine. No problem at all. So I would probably pick 0 just because it's cool to start with. So plug in 0 for X and solve for Y, and there it is. So this gives us 2. Now pick a different value for X. 1. Fine by me. Doesn't have to be an awesome thing. So plug in 1 for the X, solve for Y, and there it is. So we have our two-ordered pairs. So 0, 2, 1, 4, and now we draw a straight line. Does that help refresh your memory?
Yeah, and just the fact that you can choose that.
So let me back
Yeah.
up then. Maybe we can. How's it going to let me graph?
I guess my question was last, that first problem that we looked at, it had had several lines on it. And you had to, I don't know, apparently I forgot. Don't worry about it.
No, that last one. So let's do this one then, right here. Oof. It's really not going to be much help on this one. Really? I don't know why they do this. This is not going to be a good one to graph.
So for that other one though, we have that come up for us again. Um, so they already had lines on a graph and they wanted us,
I'll go back to it.
the questions they want us to associate like one of the equations to that graph and say like this equation is this line or I don't know. I can't remember what it was asking
So
me.
this one right here. No, they don't want you to associate it. I was just telling you what the process is. We have to graph the lines, and so what they did it for us. They
Oh,
they already said, well, here's one line right here, and then the
okay.
other one creates the other line. I was just I was just pointing that out. So no, you
Okay.
don't have to associate that on this one. On this one, all you have to
Did,
do is find the point of intersection and read off the point.
oh, excellent. Okay. So good. Thank you.
So let's see. Yeah, that's it on this one. So this one, oh, okay, now I know why. I don't know why they want. They actually don't let us graph. Okay, so this one here, what they want you to do, this is actually they just want you to take take the equation here and put it into slope-intercept form. Solve for y. So if I were to solve this top equation for y, negative 8x plus 2y equals 8. That's just more of the same thing than what we've been doing in the other one. So I'll pick up with this on the next one, but you already know the process. Is this top equation here would turn into 4x plus 4 right there. The bottom equation here, we would plug it, oops, you put it in the values here. And so this would give us 4x plus 27. Okay. So what are they wanting us to observe? What are they wanting us to observe? So we'll plug it in. 4x plus 4. So it's going to graph the line for us. And then this is 4x plus 27. It's graphing the line for us. Look at what we made when we graphed it. What are those?
Parallel line.
Parallel lines. One solution, no solution, or infinitely many solutions. How many points of intersection?
None.
None. So no solution. And that's all they wanted. So essentially this story here is just solve for y, just like you've been doing for the last 4 lessons. It's the same story all over again. They love doing that. So we're gonna submit our answer. We're gonna get it right. So good. Same story. Solve for y. And so you put your values in here, whatever they're going to be, and it will graph the line. So you look at the graph. So let's suppose I have this 4x plus 1. I'm making stuff up, okay? So how many solutions? One solution, no solution, or infinitely many solutions? How many points of intersection? Remember that's what that means in systems of equations. The number of solutions is the number of intersecting points. It's close, but do they
Yes.
cross? Yeah, they cross. It's close. There's one, and so you would read off the point, whatever value. Oops, sorry. Whatever value that is. I don't know what the value is. Okay, so let me change it. So suppose I do one solution, no solution, or infinitely many solutions.
No solution.
Because
They don't intersect.
they're parallel. Right.
Point.
Now I just changed it up. One solution, no solution, or infinitely many solutions. Look at what happened. I had 2 lines. Now I have 1 line.
Right. Just one.
When they're the same line, they intersect everywhere.
Ah, that's right.
Infinitely many solutions.
Okay.
So
Yeah.
crossing is 1 point, 1 solution. Parallel, no solutions. Same line, infinitely many solutions. That's the story that they want us to tell. Okay, so I've kept you. I apologize for the delay here. And if you have any questions that you know enough now to move forward and work on this stuff. You've known this, and I hope you're seeing that this material right here really hones in and focuses on the same concept really. And what is that? Once you get done with graphing, the biggest thing is y equals mx plus b. They really, really want you to know how to do that. And they're going to test you on that over and over and over again. So be ready. That it kind of all goes back to that. That's the big deal. This thing is the big deal right here. When you see, because we did it in this, we did it in this, we did it in this, we did it in this. I mean, it just popped up all over the place. So y equals mx plus b is the lesson. So this is coming up, but you should be planning to be done to be caught up with this part of the material by this weekend, and make that your goal, because right behind the corner is what? Another due date. Another due date on the functions, and we're gonna be prepped and ready for that. The function stuff is not that challenging. If only, and what I mean by that is you know all the material. You know everything about functions already. I'm not going to teach you anything new. It's going to take your old stuff and bring it back in. So a lot of algebra is really just once you learn about 5 things, they just take the 5 things and do a Rubik's cube with it and turn it into a different form. but it's really the same skill over and same 5 skills over and over and over again. So we're quickly going to move through the function stuff because it's not as there's about 1 or 2 new things. I wasn't exactly accurate, but there's not a lot of new stuff. It's just repackaging old stuff to make it look new. That's all it is. But the good news is it's doable. That's the whole point is because it's old stuff as new, presented new, it's really just doable stuff as well. So you can move through the homework. It's just a matter of, getting it done. And then this next week, just to kind of tell you where we're going, isn't this next week here? So that's this week. We have one more week. Yeah. We have one more week, which we'll start looking at this stuff. And so that'll leave us then we'll be what? One final week and we'll be at the end of the session. Just like that. Yeah, Jacqueline, go ahead.
I came across a problem that I had in one of my tests that it will not let me put my answer in, and I know it's the right answer. I sent you a screenshot of it. I just didn't know how to proceed from that because it won't let me type in like an exponent or anything that's needed for the answer. I don't know why.
You sent it to me just now?
I sent it to you during class, yes.
Okay, good. I'll take a look at it. It's probably, I have a suspicion as to what it is, but let me
I can't finish my
confirm.
test though, so I'm kind of in an impasse. So I just logged out of it.
Okay. Well, how about this? Oh, okay, good. You can log out. Let me
Yeah,
do
I just saved it and logged it out.
that. Okay. Well, I'll take a look at it now.
I
Okay.
had a thing. I'll send you the rest of the screenshots from my tests that I've taken. Okay.
Okay. That sounds good.
Thank you.
Okay. All right, everyone. Well, I'll get this video cooking. Yeah, you're right. I'll get this video cooking, and then let me know if you have any questions. Same thing. You're not alone. If you have questions, give me screenshots, send me your work, take pictures. I'm happy to help out.
Thank you.
All right. Hope you all have a good one.
You too.
All right. Bye bye.